Hey everyone, welcome to this. Will be hopefully a shorter video on something of I don't know, unique workflow and capabilities within HyperWorks. So I'm going to be walking through something of a proof of concept with the Design Explorer in order to optimize CBush and CBeam elements. And basically we're going to be looking at determining what type of fastener potentially could be used in these certain locations. And something kind of unique also, if maybe you're already aware of the Design Explorer, there's some great resources on our Altair community and also on our YouTube channel, which I'll highlight at the end of the video, is we use the name OptiStruct for our structural solver, but in reality, if you ever look at the .out file for the description, it's actually a proprietary enhanced version of Nastran. So I guess technically we could also call it Altair Nastran. And so what's great about that? Because the languages are so similar, we're actually able to utilize a Nastran PDF file. Apart from maybe composites, which could be absorbed into ply-based format, which is what OptiStruct uses, and maybe contacts, but those could also be quickly regenerated with our auto contact tool. Maybe other than those, and maybe a few other things, for the most part, we are able to run some basic types of model files. So if for some reason you find this workflow of using the Design Explorer really handy, don't think you have to rebuild your model completely. So I would say just give it a try, and if it runs, then you're definitely good to go to run in the Design Explorer. So I want to show that to you. So that's my quick little preview for this video. Let's get to it. So here you can see this is the deck I'm going to be kind of dragging and bringing in. CBush start PDF. I did export it from our solver, but it is a Nastran format with all the cards and those types of things, because we are solver agnostic here at Altair, and we like to work with other solvers as well. So let me go ahead and bring that in. I'm just going to drag and drop it right into the interface. And again, we're in the OptiStruct profile, and this is version 2022.1. If you do get any warning messages, they'll pop up here. Just kind of giving you a quick heads up, hey, probably should check that out. So again, it's a very simple model. I'm more than happy to share. And let's go ahead and see what we got here. So on this side of the cylinder, we have some basic loading. And let's go ahead and turn off some of this, getting a little messy. So we got some loading on this cylinder, we have some pressure on this side, we got some basic boundary conditions, but really what's important here is very basic setup. And we have here on the left side, we have our CBush elements, and on the right side we have CBeam elements. So I can go ahead and switch to elements, select spacebar, filter by configuration, and just kind of isolate these just to highlight. So these are the ones I'm going to work to optimize. But as with any workflow, really the best thing you want to do first is make sure it even runs. So let's go over to the Analyze ribbon and just submit this job. Make sure it gives us some reasonable save there. And put in our number of cores and hit go. So it's a very small model, and OptiStruct is happy, so we can just definitely proceed from there. All right. Something else we could do, we go to our post ribbon, so maybe we're not quite aware of what the results are. We can go ahead into our results and go ahead and add in what we just ran. Because it's this BD format, it has output requests already built into it, so we could load a OP2 or an H3D. That'll always come out as default. And once we do that, we can see this gets populated, and we can go ahead and add a contour. We could do displacements, basically anything that's in that request. So maybe we'll just do some basic stuff like plotting the stresses, and maybe that's not so interesting with beam elements, but here you can see we can visualize the results. So give you a heads up on what your constraints may be if you're doing an optimization. So that's a couple things I want to review here. Let's go back over the Design Explorer. Let's go ahead and turn our contour off, and then go back to selecting our elements, isolate, and lock the view, because I really don't care about the loading boundary conditions at this point in time. So you've done your analysis, and you kind of had an idea of your factors of safeties and stresses and displacements, and you know your allowables and constraints for design. So let's go ahead and add a DOE. It's always a good place to start, and this will really help you kind of fine-tune your optimization. Again, let me navigate over to my folder, just copy and paste it, and stick it in here. And one note, at least for this version, it's always good to have this on a local drive, not through a shared drive or Microsoft OneDrive and those types of things. So keep it local, stable, and faster. So there's my DOE, there's my study. We'll go ahead and close that. We can go ahead and open up our browser. You can see we have my DOE. And at this point, we're going to go ahead and set up, I'm actually going to be sizing those beam elements and the properties. So again, let's go ahead and go back and focus on those beam elements, isolate. I could even save that as a view if I really wanted to. I think it's probably a good idea, actually. Okay, apart from spelling. So let's go to size. This is automatically going to pick up, so if I pick up the C-beams, it's automatically going to pick up some of the properties. And particularly with C-beams, maybe if they're representing a fastener, you might want to have discrete values for them. So, we'll want to go from maybe 2, and this could be, Twinkies, millimeters, inches, I don't know, feet. So I don't really have a unit system quite built into here, so just kind of leave it to your imagination. This is a kind of a proof of concept, really just kind of highlighting the process. So we'll hit enter, 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 and then we get our nice little steps. So it's not going to give us a 2.221 something or other. It's going to give us nice discrete values. And now it's happy, and I hit create, and it's going to go ahead and populate my design variables. And this is based on, again, those properties. These each have their own property that it's going to vary independently. If I wanted a single property, because I don't want to drive my manufacturing engineer crazy on 12 different types of fasteners, you could also just have a single property and it'll pick the right one. So just buy one box of fasteners. So I didn't name these very pretty, but there they are. And then we'll go ahead and go over here and select our CBushes. These ones, because of the properties that's associated with them, are more stiffness related. So you could do this discrete as well. But for the sake of this kind of proof of concept, I'm really just going to focus in on one stiffness value. You could do all of them. Obviously, it's going to make your runs a lot longer, just more iterations. But that's really up to you to run the job overnight type of a thing. So again, let's just focus on the workflow and capabilities. So we have all of our design variables. They're all enabled. And then we'll switch on over here. And we have a whole bunch of other ones. I'm not going to go through them. This is mostly focusing on the CBushes. And I want to check some responses. So maybe I want to look at the stresses in my beams. Go ahead and grab those ones. And it's always kind of a good idea to explicitly select your subcase. You don't have to, but it's always just a kind of a good practice. And so we got that guy, and we'll go ahead and hit play. We have our stress. All right, happy there. And then with the C-beams, or sorry, the C-bushes, we're going to look at the forces. Again, we'll go ahead and explicitly, we have one, but I found it always good practice. So we're going to extract the forces here, extract the stresses there, and at this point we really can run a DOE. We're just looking at the responses, but it's kind of boring. What if we wanted to do some derived stresses? Because stress in and of itself, or force in and of itself, isn't really all that interesting. Maybe you want to do some factor of safety. So what we can do is create a new one. So double click there. Maybe I want to take my stress and divide it by some type of allowable, so I can get like a factor of safety. So I'll just derive factor of safety and hit create. There we go. And the next one will be something a little more interesting, actually. And this is something, if you're a little more familiar with, close this, I'm trying to pull open, a little more familiar with Compose, is we can actually register these functions. This also works for the matrix browser and hypergraph. But I have some very simple equation. It's obviously up to you, but basically I'm going to take in 3 inputs and then basically go run through an equation and then output some stress value. So again, this is more like a magnitude. This is not von Mises really, but again, it could be any equation you want. And all you got to do is highlight it, right click, and register the function, and then it'll be stored and referenceable. So again, just open Compose, save the name, register a function. And once we do that, go to the derived, and now we have a list of different equations that we can reference. So I'll select this one, and actually I need to create some other force outputs for this. So I go over here and go duplicate and duplicate, and then let's change this to X, change this to Y, change this to Z. Again, it's really up to you. And then we'll go back to our derived case, and that's our factor of safety. And then I'll do this von Mises, and then kind of select in here. Let's get those parentheses in the right location. And then there's Y, there's Z. Just filling this out. And create an update. So then we can go here. This will be my derived F something. So then what we'll have is all of these responses will be output, and we can review them. So the next thing we want to do is run a design of experiment. And again, the value in doing this is to be able to determine which design variables we may be able to eliminate from an optimization, making the optimization more efficient. Something else I wanted to quickly double check, and this is always important, particularly if you're bringing in results or different file formats, is I want to go over to my load case, and you want to make sure that, let me pull this open here, that all my output information is there. So if I'm requesting stresses to be calculated, then I need stresses. If I want displacements, I need displacements. So it's always good to double check. And staring at me. Okay, there it is. So now we have our stresses, element forces for my force calculation, and displacement. So now it should be good to go to run. It's always good to check that. Otherwise, it'll just give you an error, and you're going to be wondering what the heck's going on. So let's just do a quick test run. Maybe let me do 5 for the sake of time. And also, maybe I'll just pause it here too and let it run, not to waste anyone's time. So it's going to go and do its processing, loading. It's actually coupling with HyperStudy, and then HyperStudy is managing the job submissions with OptiStruct, and then basically storing it. And then if you go into your, if you actually go into your file where it's stored, you can see it create all of these files. So if you need to reference one of them later on, maybe you really like run 3, it'll be stored here in your DOE. So run 1, run 2, and then it creates run 3. So again, it's doing it all for you. And also your nominal run is located here. And then your study file. This will be your hypermesh database, which kind of has your setup. So go ahead and pause it here and let it finish, and we'll bring the results in. And there we have it. Okay, again, just kind of a proof of concept. And we'll go ahead and close this, and let me bring my model back here. And go ahead and load in the results. And here you can see we have our inputs, so maybe we'll do, let's just look at one of our beams and then we'll look at our responses. So there's that derived one, and then there's derived factor of safety. So good, it works. So if for some reason you get some like crazy number here, you need to go look back at, make sure your output requests are being called. Otherwise it's running, all those equations and setups are running. So cool. We could also do some comparisons if we want to compare run to nominal. So lots of different things we can do. This isn't an exhaustive video on Design Explorer necessarily, mostly just highlighting the capabilities to select those beam and bush elements. So again, we could just kind of walk through. So this is your summary table. You can do like a comparison looking at the inputs and responses. We don't have any goals yet. And next we can go to the, if we hover over here, linear effects, so we can actually see which dimensions are contributing to the stresses, basically our responses. And this is where we can get an idea of where, so maybe we don't necessarily, if stress is kind of our primary driver, maybe we don't need to use dimension 1, and so forth. Kind of just a good look. So we have the negative positive correlations. We could do some, I only have a few runs honestly, so my fitting here is not really good, but what we're able to do actually is just kind of move the values around, and then kind of look at the value of the responses. So if I stiffen that one up, not too much was happening with this one, so that kind of makes sense, but basically it's gonna change your responses here manually, so you don't have to run these iterations. So okay, so I'm not gonna kind of go through the whole workflow. You can also plot these and so forth. So again, if you really want to dive into those more details, I will show you some of the additional resources that we have. I want to go back and I actually want to kind of set up an optimization real quick. So, and that was kind of a unique thing here, since we're not really looking at the displacement, or let's see here, mass. We're not really looking at minimizing mass in this case. So I'm gonna go ahead and grab these, say hide, again lock my view, and this time we have some constraints. So maybe I want to constrain my factor of safety to an upper bound of 1.5, because you don't want to over-engineer it. Because of how I have this set up, potentially you could just max out the fasteners and satisfy the objective. The next one is maybe want to constrain the von Mises stress. Again, that could be like an upper bound of, I don't know, 800. And we need one more response, which I'll try to minimize, and that will be my displacement. So let me go into my displacement, and let me hide some of these. We want to focus on the beams. And I will grab these, and then we'll grab these nodes. Yes, yes, yes. Again, always good to explicitly define the subcase, and we're happy. All right, so that's the displacements over there. I also want to go over to my displacements here, and I also want to add some additional nodes. So this will be by path. Bear with me, I don't use a space mouse. Let's see here. There we go. All right, now we're all happy. We've loaded in all of those. So now, we have our constraints, and last but not least, we need a response for our objective. And what we're going to do with that is actually try to minimize displacement. So basically what I'm telling it to do is stiffen up the structure at certain limits to those stiffness values, limits to the size of the beam elements. So at this stage, I have all the necessary inputs for an optimization. So let's go on over here. And now that it sees that I have the objective, my optimization has been enabled. So again, I'll do, let's see, maybe 25 runs, something along those lines, and then we'll go ahead and hit run. And yes, we can just overwrite those files, and then I will just pause it here and let it go and see in a second. All right, so we got our job finished. It'll run 50 iterations, possibly for an optimization. And then we go on over here, and again, like we did for the DOE, we go ahead and load in the results. So here we can just kind of scroll through the different runs. Again, just kind of observing, what the values are, and we can also look at our, factors of safeties, and it also is going to give us conditions, best iterations. So there are some that are feasible, and so forth. So sometimes you might have red ones which are violating, or you might actually be fortunate enough on your first go to get a feasible and optimal design. And we can scroll over here and look at design 22. And so again, as I mentioned, if we go into our files here and go to our approaches, optimization, go to run 22, this is going to be your FEM file right here. So that's going to be your model with all the appropriate properties for the stiffnesses and the beam elements, etc. So you don't necessarily have to kind of import another file onto another model, etc. to overwrite it. So we have also, if you like for some reason any of the other models, they're already built for you. So some of the other things you could do is do some, again, go through looking at how the iterations went. We can look at so let's maybe look at how the displacement changes over the course. So we can see that displacement converges to a certain location. All right. So last but not least, again, we could also look at some of the thresholds. So maybe, let's see here on the X, we could look at derived beam factor of safety, and we could look at maybe one of the bush elements and look at maybe a threshold. So here's our factor of safety, here's our threshold value, and then here's the stiffness values for this CBush element. So we can get an idea of where all the iterations are falling. The large icon is for the optimal, and then we can also go in here and do some inspecting. So if we wanted to look at maybe which run this one is and what its values were as well. So again, not an exhaustive presentation, but if you go on over to our Altair community and search for Design Explorer, we have a ton of other great videos kind of highlighting the overview of its capabilities. Or if you'd like, you can also go over to our how-to channel and look for some additional videos there. So again, hope you found this helpful and appreciate your time, and take care.